During the 3 Skylab missions, exercise was a vital element for crew performance. This astronaut can be seen here working on the upper body strength exercise machine. This picture shows Skylab lifting off the pad, being launched into space by the Saturn S-1B booster. This picture, taken by the Skylab 2 crew, shows the makeshift solar blanket and the single solar panel of the damaged Skylab space station. This black and white image shows Skylab in orbit. Note the black Apollo docking adapter in the foreground. This picture shows the Skylab crew working inside the space station. Located on the left side of the picture is the Skylab Solar Observation Control System. This image shows the Solar Observatory package and high-gain antenna system. In this picture, an astronaut can be seen in the lower body resistance unit. This medical piece of equipment was designed to test blood pressure and conduct other medical activities in a zero-G environment. This picture shows an astronaut weighing himself on board Skylab. This picture shows an astronaut conducting medical research during a Skylab mission. Located at the Johnson Space Center is the neutral buoyancy tank. This huge swimming pool was designed to give astronauts a realistic feel of what it would be like to work in space. This picture shows an astronaut eating freeze-dried food on board Skylab. The astronauts typically ate 3 times a day, and the average mission lasted 60 days. This color image of Skylab shows Skylab high above the Earth. One of the primary goals of Skylab was research. This picture shows an astronaut conducting an experiment with an EVA jetpack. This system was later perfected and is in current use on board the American Space Shuttle. This picture shows an astronaut conducting medical research on an exercise bike during a Skylab mission. This image shows an astronaut in the neutral buoyancy tank at the Johnson Space Center. This huge swimming pool was used to simulate the effects of zero-G gravity and help the astronauts prepare to do work in space. Skylab was designed from spare parts of the Apollo Saturn V rocket, primarily the S-4B third-stage booster. This image shows the Skylab 2 crew leaving the vehicle assembly building and departing to the launch pad.
Okay, Houston, the meteoroid shield area is solid gold.
Roger, copy.
brief description, it is suspected solar wing 2, right? 2 is gone, completely off the bird. Solar wing 1 is in fact partially deployed, and the reason that you've got different readings, not symmetric between your 3 solar panels, is there's a bulge of meteorite shield underneath it in the middle, and it looks to be holding it down.
Roger, copy.
This image shows 2 astronauts conducting medical research on board Skylab. Medical research was one of the primary objectives during this program. This image shows the Skylab 2 crew returning to Earth and climbing out of the Apollo command module. This picture shows an astronaut conducting medical research on board Skylab. This image shows the Skylab crew during a meal period. Skylab was divided into 5 areas. One of the areas was crew habitat, which included a dining area and a window. This black and white picture shows a top view of Skylab. Please note the solar panels located on top of the telescope and the makeshift solar blanket. There were multiple EVAs conducted to repair Skylab during the 3 manned missions. This image shows an astronaut conducting an EVA to repair Skylab. There were over 15 EVAs conducted over the 3 missions.
The unmanned launch of Skylab by a Saturn V rocket in 1973 was called Skylab 1. Almost immediately, problems developed. A meteoroid shield was accidentally deployed during launch and was torn away. It also tore off one of the 2 main solar panels, and a piece of the shield jammed the second solar panel. Skylab 1's thermal shield was gone, and its main power generation system wasn't fully functional. With only the observatory's solar panels still functioning, the temperature inside the space station rose to over 125 degrees Fahrenheit. Equipment damage and noxious gases became real threats. After an intensive 10 days of problem solving, the first Skylab crew was launched to try to repair the damage.
This was Skylab on the final day of the first manned mission. The crew had this last view as they made preparations for return to Earth. It had been a successful mission. The large majority of scientific objectives were accomplished. But the bright orange sunshade, the single solar wing, presented a striking reminder of a mission that was something more than routine. A mission that gave new meaning to the term manned spaceflight.
T-minus 13, 12, 11, 10, 9, 8. We have ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. And we have liftoff. The Skylab lifting off the pad now, moving up.
It was the afternoon of May 14, 1973, when the unmanned Skylab Saturn workshop was hurled aloft at Cape Kennedy, on the way to its assigned orbit 236 nautical miles in space.
When Skylab 2 mission crew members Charles Conrad, Paul Weitz, and Joseph Kerwin were launched on May 25, 1973, their first task once aboard the space station was to try to unjam the solar panel. Unfortunately, the attempt was unsuccessful. Testing the cabin atmosphere for fumes and finding it safe, they entered the station. Though they were able to lower the temperature in the station by pushing a sunshade through an airlock, they still had to contend with a shortage of electrical power. During a 3.5-hour spacewalk 2 weeks later, the men cut the strap holding the solar panel shut and restored power. This allowed them to carry out the planned experimental program during the remainder of the mission and to set a new space endurance record of 28 days. In 1965, Charles Pete Conrad Jr. flew on Gemini 5 and then commanded Gemini 11. In late 1969, he was the commander of Apollo 12. During this mission, he performed scientific experiments on the lunar surface and was one of only 12 astronauts who landed on the moon. Conrad was also the commander of Skylab 2. During this mission, in May of 1973, he was instrumental in helping repair the damage that Skylab had received when it was launched. Paul J. Weitz was a pilot on Skylab 2 in May of 1973. During this mission, Weitz was instrumental in helping repair the damage that Skylab had received when it was launched. Weitz was also the commander of the first flight of Space Shuttle Challenger. This flight was a successful 5-day mission that ended on April 9, 1983. Joseph P. Kerwin is a physician as well as a United States astronaut. On Skylab 2, Kerwin was a science pilot. During this mission in May of 1973, he was instrumental in helping repair the damage that Skylab had received when it was launched. On July 28, 1973, the Skylab 3 mission put Alan Bean, Owen Garriott, and Jack Lousma in the space station for 59 days. Their work included further repairs, Earth and solar observations, and tests of a spacewalk maneuvering unit. The crew also conducted a fascinating classroom in space, including a demonstration of zero gravity. Owen K. Garriott was a science pilot on Skylab 3, launched in July of 1973. This mission put Garriott and his fellow crew members in the space station for 59 days while they worked on repairs of Skylab, made Earth and solar observations, and conducted a fascinating classroom in space, including a demonstration of zero gravity. Garriott was also a mission specialist on the first Skylab mission, Space Shuttle Flight STS-9. Jack R. Lousma was a pilot on Skylab 3, launched in July of 1973. This mission put Lousma and his fellow crew members in the space station for 59 days while they worked on repairs of Skylab, made Earth and solar observations, and conducted a fascinating classroom in space, including a demonstration of zero gravity. Lousma also served as commander of the third Space Shuttle mission. The third and final crew to inhabit Skylab set the U.S. space station endurance record of 84 days in orbit. During this successful Skylab 4 mission, launched on November 16, 1973, crew members Gerald Carr, William Pogue, and Edward Gibson photographed and studied the comet Kohoutek and a giant solar flare. Medical and material science experiments investigated the unique conditions of weightlessness. 2 additional records were set on this flight: the longest EVA, 7 hours and 1 minute, and the greatest total EVA time for a single mission, 22 hours and 21 minutes. On this mission, scientists had an opportunity to study the physiological effects of a long flight on the crew. They also learned that the astronauts have limits to their good temper. The crew briefly went on strike against what they perceived as excessively demanding schedules and requests from mission control. This confirmed that the physiological as well as the physical well-being of space travelers is an important factor, particularly on longer missions. Gerald P. Carr was the commander of Skylab 4. This mission, launched in November of 1973, conducted medical and material science experiments, investigated the unique conditions of weightlessness, and set 2 records, one for the longest EVA and the other for the greatest total EVA time for a single mission. William R. Pogue was a pilot on Skylab 4. This mission, launched in November of 1973, conducted medical and material science experiments, investigated the unique conditions of weightlessness, and set 2 records, one for the longest EVA and the other for the greatest total EVA time for a single mission. Edward G. Gibson was the science pilot on Skylab 4. This mission, launched in November of 1973, conducted medical and material science experiments, investigated the unique conditions of weightlessness, and set 2 records, one for the longest EVA and the other for the greatest total EVA time for a single mission.
Welcome to Skylab. Welcome to Skylab. Galley. Crew quarters. Galley. Cryogenic. Cryogenic storage. Welcome to Skylab.
The Skylab astronauts conducted a wide variety of experiments in basic and applied science, testing systems and equipment, evaluating their potential for future space vehicles. They also took advantage of the zero-gravity laboratory to demonstrate phenomena difficult or impossible to duplicate on Earth. Throughout the missions, crewmen kept a close check on themselves to see how their bodies were responding to long-term zero gravity. They exercised daily, stressing their bodily systems to the maximum to make sure the heart, the lungs, the muscles, all the bodily processes perform together the same way in the absence of gravity. In May 1973, Skylab was placed in Earth orbit to answer a fundamental question. Could human beings live and work effectively for long periods in the weightless environment of space? To test that question, 3 separate three-man crews occupied the space station for 28, 59, and 84 days. Like all of us, their entire physical and mental being had been shaped since birth by the ever-present force of Earth's gravity. Now, suddenly, they had complete freedom of body motion in all 3 dimensions.
Welcome to Skylab. Galley.